The James Webb Telescope shows us the marvels of the universe in phenomenal detail. As the most impressive space telescope ever constructed, Webb is 100 times more precise than its predecessor, Hubble, and could even effectively see into the deepest secrets of those structures that seemed completely imperceptible to the instruments of the past. And while the billion-dollar gadget has already revealed one or two infinite secrets, it also uncovers the stunning beauty of the universe at the same time, from smiling galaxies to an infinite question mark and an unmanageable multitude of stars. Prepare to wonder at the arrangements of the universe in dangerously sharp magnificence that will leave you totally astounded. Smoking is undesirable, but space travelers can't resist the urge to reach for a cigar regularly. Luckily, however, this specific cigar star doesn't produce any putrid smoke, but rather bursts of star formation, which have now been thoroughly examined by the James Webb Telescope. Otherwise known as the cigar galaxy due to its unique shape, Messier 82 is famous for its entrancing starbursts. Essentially, this refers to periods of rapid and efficient star formation. However, most starburst galaxies are so distant from us that studying them in detail is quite challenging. At a distance of 12 million light-years, Messier 82 is a welcome exception. Although the spiral galaxy in the Ursa Major constellation appears almost smaller, it is a prolific star producer. In fact, it births new stars at a rate nearly 10 times greater each year than in the Milky Way. Previous observations were often hampered by the thick veil of dust and gas that typically occurs in these galaxies. Webb's infrared view, however, is now able to break through these blinders and, with the help of its near-infrared camera, NARCam, even capture images of the actual starburst center. While the dark brown dust veins permeate the glowing white center of Messier 82, even in this infrared image, Webb gives us the structure in an extraordinary degree of detail. For instance, we can see small red spots in the middle, where young stars make atomic hydrogen glow. The green areas, on the other hand, represent the opposite end of the heavenly signpost. Most of these concentrated, iron-rich regions are merely remnants of supernova explosions. The brown dwarfs outside the Milky Way are another fascinating discovery. Is it a star? Is it a gas planet? No, it's a brown dwarf. In simple terms, these objects can be described as a sort of intermediate stage between a planet and a star. Typically, brown dwarfs weigh between 13 and 80 times the mass of Jupiter. On one hand, they are too low in mass to ignite hydrogen fusion within them. On the other hand, they are massive enough for deuterium fusion to begin. Surprisingly, these particular celestial bodies can sometimes float freely through space without being gravitationally bound to a host star, much like a planet. At the same time, brown dwarfs also share some qualities with exoplanets, such as storm patterns or atmospheric structures. And while Hubble has previously shown us that the emission cloud NGC 602 is home to a series of young, low-mass stars, Webb's sharp eye has even observed the first potential brown dwarfs outside our home galaxy in detail. The Little Magellanic Cloud, located about 196,000 light-years away from Earth, features an image of an open star cluster in a beautiful cloud of gas and dust in and around the gas cloud. However, various distant galaxies also grab our attention, as do a few stars that are much closer to us, giving off a radiant glow. The glowing quality of the universe is striking. And speaking of shimmering wonder, compared to the image that Webb captured of Westerlund 1, the structures of NGC 602 nearly look like faint fireflies. Located in the constellation Era, Westerlund 1, discovered in 1961 by Swedish astronomer Bengt Westerlund, is nothing less than the largest open star cluster known in the local group. A brief clarification. Scientists refer to a group of galaxies, including our Milky Way, as the local group. The abundant star population of Westerlund 1 means that 50,000 to 100,000 solar masses are found in a region whose diameter is less than 6 light-years. It's a large stellar population, but one that is too short-lived, with explosive consequences. Experts estimate that more than 1,500 supernovae will occur here in less than 40 million years. At the same time, Westerlund 1 serves as a star lab for scientists to study extreme celestial physics. Here, They can understand how the most massive stars in our galaxy live and die, and how cosmic winds, supernovae, and other expelled material impact star formation in the surrounding area. Now, regarding the dance of the galaxies, it almost looks as though the two galaxies of ARP-107 couldn't be more joyful about their destiny. In detail, we are dealing with two interacting galaxies in the Leo Minor constellation, a good 440 million light-years from Earth. While the larger spiral and smaller elliptical galaxies are on the brink of colliding due to their vast dance, the orange and red star-forming regions, made of gas and dust, together form a sort of smiley face. But the ring structures are not the only things Webb has exposed here. Thanks to the mid-infrared instrument, MIRI, we now also know that a nearly straight line of stars exists here, stretching between the two galaxies. The main point, however, is that in a few 100 million years, the two galactic partners will have merged to form a much larger, irregularly shaped galaxy. At the edge of the Milky Way, Earth is about 26,000 light-years from the center of our home galaxy. However, the so-called dwarf clouds 1 and 2 are separated from the core of the Milky Way by a distance of 58,000 light-years. Thus, they are located in a region that scientists consider the super-outer galaxy. A group of experts used Webb's near-infrared camera to investigate specific regions of the two subatomic clouds, revealing entirely new parts of these remote areas, which hide star clusters as well as cosmic nurseries. Although the two clouds are part of our cosmic home, they are relatively poor in elements heavier than hydrogen and helium. As a result, their structure is more reminiscent of dwarf galaxies or the early Milky Way. And while Webb confirmed the previously suspected presence of a subcluster in one part of the image, we also see faint planes extending in various directions from the brilliant structure. The astronomical inquiry marks numerous cosmic designs, joined by a giant question mark and another in a real sense, as we can see in the following picture. The corresponding exclamation mark also appears to have a permanent spot in the universe. In fact, the ESA stressed that the picture is by no means a fake or a scam, but rather a couple of effectively forming young stars, scientifically designated Herbig-Haro 46 of 47. Although the snapshot has the potential to become an image, stargazers, unlike the Webb, are not making a big deal about the possible mark arrangement. Their principal focus is on observing the star formation, a brief glimpse into the planetary nursery. What is, perhaps, just a reflection cloud in the constellation of Perseus by definition is also another amazing example of the fundamental processes that occur in the depths of space. Situated around 1,000 light-years from Earth, the structure NGC 1333 is a massive star-forming region that is home to countless stellar infants, younger than 1 million years. The mass of this area is estimated at around 450 solar masses. But that is not all, because while the Webb's sharp infrared view also penetrates the dusty shroud, in this case, we also see gas and dust disks in the picture, from which new planetary systems may arise. The secret complexities of Messier 106 in a galactic setting. Messier 106 is just a stone's throw from us. Regardless, the enormous house cat would still need to cover a distance of 23 million light-years. As one of the closest and brightest barred spiral galaxies in our area, this universe also has a central very large black hole. But interestingly, this one seems to be especially active compared to the massive beast at the core of the Milky Way. It devours significantly more material, and while the odd monster actively consumes dust and gas, Messier 106 also has another beautiful feature. It has two additional irregular arms that are only visible in the radio and X-ray spectrum, not in the visible range. This is because these arms are not made up of stars at all but of hot gas. Astronomers suspect that their existence is due to some sort of feedback effect from the black hole. In detail, they are likely formed by expelled material, which is created by the violent process of gas swirling around the gravitational beast. Thus, an interaction is set in motion that can be compared to a wave hitting a stone near the shore. The cosmic gem ring, where the gravitational lensing effect meets a distant quasar, the end result is an image suggestive of a ring set with gems. In simple terms, gravitational lensing causes the light beams of distant sources to be affected by objects that appear to lie in front of them. In this context, the designs behind them can be optically amplified, distorted, or, as in this case, duplicated. In detail, we see here with RxJ131d231, an active cosmic core 6 billion light-years away, which is affected by the strong gravitational field of a curved galaxy before it. The cosmic gravitational focal point presents itself as a small blue in the middle of the ring, while the orange, glowing pearls clearly show the same quasar in multiple versions. For researchers, however, the gravitational lensing effect is much more than an optical trick. After all, it sometimes makes objects visible that would otherwise be too far away or too faint to be studied in detail without this natural effect. And if you now look below our video, you will quickly find the like and subscribe button. We would love for you to join our community so that you can stay up to date. We'll see you soon.